Hi, today we're going to be talking about the forces in structural members. The three forces are tension, compression, and shear. The first force, tension, is when the members of the particular object are stretched or pulled apart, resulting in the member elongating. The second force, compression, is when the members of the object are pushed together, causing the object to shorten. The third force, shear, is when one side of the object is pushed down and the other side is against. So one force is pushing down, one is pushing up on a different axis than the axis the member is in.
The top fibers of the beam are in tension because they are being pulled apart, as evidenced by the dark blue arrows. The bottom fibers of the beam are in compression because they are being pushed together, as evidenced by the red arrows. Shear forces exist on this cantilever beam because the structural support is pushing up on one side of the beam, while a person or object, the weight, is pushing down on the other side of the beam, causing a perpendicular force.
We can show the cantilever beam in an actual experiment. For example, when creating this cantilever beam, we have the force securing one side of it and the other side loose. We can see the forces as we push down, that the other force is causing the ruler to bend or slide against each other because of the force pushing up. Notice how the ruler comes closer together at this part, so that is tension, or that is compression, and the forces are sliding apart as I go down on the top, so that is tension.
For our experiment, we're going to use this water bottle as a weight to see if it can support, if this cantilever beam can support the weight of the water bottle. I've attached it using a paper clip, and we'll see if it supports. Surprisingly, the ruler did not break, yet if this were an object or someone standing on top of the cantilever beam, they would fall down, or it would slide off. We're doing this experiment again with a wooden cantilever beam this time instead, and we'll see if it supports the weight of the water bottle. In this case, the wooden beam is more flat and much more sturdy compared to the plastic ruler.
When looking at the forces, we can see how our two different members were affected differently by the forces. With an equal weight on the plastic ruler, the ruler bent more because it didn't have as sturdy of a membrane and particles were easier to slide against each other. For the wooden one, the force was the same, yet there was a less of a end result in terms of the bend because the members were less likely to slide against each other. So shear was decreased, which means that there was less tension and compression as well. A diving board is a real-world example of a cantilever beam. You see the force on this side makes sure that it's stable, while the lack of force on this side makes it unstable. So when a diver jumps off, the beam goes down, causing shear, tension, and compression. And then they jump off, and that is how they get higher and dive in. Cantilever beams of this kind, or diving boards I should say, are very dangerous for this reason, and to own one there is a tax that you must pay.
Thank you for watching our video on structural member forces.